Have him, and he's going to talk to us about what's going on with Aerostar. Jim?
Thanks, Jim. I guess I'll use this. Okay. Well, thanks for inviting me. And I thought that we might have some new owners or prospective owners, so I wanted to do a little abbreviated history on the Aerostar. This was the original designer, Ted Smith, and he had worked previously for Douglas Aircraft Company and had developed some airplanes and for the military and also the Jet Commander. In 1963, I think this magazine article came out, and it was 1964 maybe, and that was the four-cylinder, twin-engine, four-cylinder powered Aerostar, and they certified that as the Aerostar 400, two-bladed props. So his idea was, let's make a piston twin airplane that's faster, safer, more dependable and than anything that you could buy at the time. And he liked the mid-wing configuration that he had on the A-26 airplane that he was responsible for designing. So he kept that idea, and it was supposed to be a lower drag configuration. He also thought about a high-speed airplane. He just made the Jet Commander, so he wanted to make the Aerostar capable of flying with jet power. And the idea was thicker skins, and for cost savings, he also wanted the tail, the vertical fin and the empennage tail sections to all be the same, fewer ribs, way fewer ribs and structural members with a much thicker, heavier skin. And so that was going to reduce cost to manufacture the airplane. It started in 1963, and there's the first airplane. Certified in 1967, that was with the four-cylinder engines. I'm amazed that Ted, with all that experience, designed that airplane, and it came in probably 500 to 1,000 pounds over his calculated weight. And so he had to put six-cylinder engines on it, and he got that certified shortly thereafter as the Aerostar 600, and then amazingly, that same year, he gets it certified as a 601 with turbocharged engines. That would be that's not possible today. Yeah, but his idea was, let's just go ahead and get her done, and he used the FAA. He was able to do his own certification, but he said, no, we'll use the FAA, and if we design the airplane past minimum standards, it should be no problem to get it certified, and he was right. And Eric's father was his right-hand man, an engineer, and kept the whole organization together. I think Ted was a little volatile. I talked to a pilot one time, and he told me the story about how he went somewhere and he was talking to the chief engineer that was already there, and he came in and he says, "Hi, Niels." Yeah, he says, and Niels says, "How you doing?" And he says, "Well, Ted just fired me." And he said, "Again?" Yeah, so he hired him back. But he was that way. He kind of blow up, and Eric's father, I understood from Bill Leeds, was the guy that kept everybody together on the same path. So as soon as Ted got the airplane certified, these airplanes, shortly thereafter, they sold, the investors who had control of the company decided to make a profit and sell it to a company that was a willing buyer, Butler Cement, American Cement. And then and when they decided that was a bad idea, Butler Aviation agreed to buy it from American Cement. And that didn't go well either because they couldn't make the first $10 million payment. So it went back to American Cement, and in the meantime, Ted was developing new airplanes because, you know, the headline there on the right says, "Tough old Ted Smith is back again with new airplanes to carry on after the Aerostar." And he had, you can see there, he has a, I forget the name of that military airplane that had engines in kind of ring spars on on the wing. But he also had a stretch version that he wanted to make, and he used that as leverage. And this was what he called, and he couldn't use the name Aerostar because it was a trademark name and he had sold it, and so he called this airplane the Superstar. And he raised the tail to more of a cruciform tail, and he had 350 horsepower engines, and he also had a bigger window like the Aero Commander had on the side for better visibility, I guess, or just to make it different. And the emergency exit was in the roof. And he said I understood the story, was he went back to American Cement and said, well, your airplane's obsolete. I'd like to buy it just for the facilities, and we can use a few parts, but we're going to make new ones that are a lot better. So we'll pay you something, but it's not going to be a lot, So he got a great deal and bought the airplane back. So here is an Aerostar log back in the day, in the 70s, and he announces that he's bought the Aerostar back, and he acquired all the assets, and he didn't change a thing. He just put the airplane back in production. So this is where I worked, and Don Smith worked on the other side where all the new airplanes were being assembled and went out that door, and then when they were all done, they came around the other side of this big World War II hangar, and then we tore them all apart again because we had to put in all the options like boots and hot props and air conditioning and avionics. The airplanes were all certified like a green airplane. And then they came in and were spec'd out for every dealer out in the field. Not a very efficient way to do it. This was the big hangar. This is a big building on Skyway Drive where they built the fuselages, and they were all brought over on a trailer, and then they put the wings on in the big World War II hangar. This was the same Superstar that they then stretched, and they put 8-cylinder Lycoming engines on it, and they called it the 800. And that was 1976, and they put the Stars and Stripes paint job on it as a centennial paint job. And then shortly thereafter, Ted passed away, and but he did feel a great sense of accomplishment, of course, that he deserved, building the Aerostar. And then in 1978, the company got purchased by Piper, and not a whole lot changed. The same employees, the same location. They did build a brand new facility in Santa Maria, California. I never worked there, but I guess it's quite nice. And of course, they changed the brochures. And when I left, I went to work for a company called Mock and Ink. And I had a partner, Steve Spear, and Steve worked at Aerostar too, and he was a really sharp engineer, and I became good friends with him, and he said, hey, why don't you find us an airplane, and we'll put the 350 horse Lycomings on it, and then as soon as you have one, you can come to work up there. Just sell your house and put all the money in the company. You can find a 3rd-story apartment in a house that I know of, and I said, boy, that sounds like a great idea. But I said, I'll work for this dealer for a little while, and that was in San Ynez, California, so I did that. And then I eventually did do all of that and move up to Spokane, Washington, where Mock and Ink was in business, and they had done previous modifications to things like the Aero Commander 112. They took out the turbocharged 210 horse engine, put in a 300 Lycoming, and they did. And then they were working on the Bonanza when I came in there, and that was to take the 285 horse engine out of the Bonanza and put in a 350 Lycoming turbocharged engine. And that was a successful project. But we did find an airplane. The owner was in North Carolina, and he gave us this airplane and said, okay. And we gave him a deal. At that time, we could buy one 350 horse Lycoming engine for the Navajo, Of course, we needed two, so we bought two of them at $15,000 each. The next year, they raised the price to $30,000 each. I guess they thought, well, you know, maybe there is a market for that. We're leaving a lot of money on the table. And we sold the conversion to, this was our first airplane, was called the Superstar, and we later renamed it Superstar 2. But it had 350 Lycoming engines, and it had intercoolers in the wings right here and here, and they were designed after the de Havilland Mosquito. They had the radiators in there, so it was a pretty sophisticated design, didn't cause any drag. And we got into, we still didn't own the Aerostar, we're still Mach and Inc., and this AD note came out and said, hey, one of the Piper test pilots flew the airplane and said it doesn't meet the certification requirements for power on stalls. You can't hold the heading into a full stall before, you'll lose the heading before the airplane stalls. Okay, so we tough tested the tail on the airplane. First we went out and we had a mentor pilot who did all the test flying at the time, and we decided that he should go out and fly that, and we'll fly in formation with him, and we put tufts on the tail just to see what's going on. And anything past about 10 degrees of deflection of the rudder, it stalled. When I say stalled, it stalled very slowly. All the tufts started moving, then some more started moving, and we discovered that they stalled in a cone shape right behind this hinge point and also this hinge point. And that's because the leading edge of the rudder sticks out into the airstream. Okay, but those areas are not streamlined. You see that? That becomes a stall strip when you stick it into the airflow. So it was a cone shape where the tufts started moving, then a cone shape here. Then we discovered, well, it trips off of this sharp edge when you deflect the rudder. So pretty soon, when you got to 30 degrees, the whole rudder was stalled. And I understood, I'm not an aerodynamicist, but I understood from those that were, that most of the power of the rudder, or the vertical fin deflection of the airfoil there, 90% of it's the low pressure area. So if you stall that out, you lost most of your rudder power. You don't feel it because you're pushing that rudder into the airstream. So you feel like, hey, I've got rudder power, but you lost 90% of the lift, or 90% of the rudder power because the lift is going away. And Piper decided that they would put this water rudder, I don't know, in it. It didn't quite meet the requirements, but the FAA let them go because at the time the airplane was certified, you were required to run 90% power in the power on stall, and then the regulations were later changed to 75%, and I understood this wouldn't work at 90, but it did work at 75% power. So anyway, so we designed some changes here. We attached this part to the rudder itself and have this aluminum casting, which is designed to smooth the airflow. And we also have aluminum castings here and here that stick out a little bit, but when the leading edge of the rudder is fully deflected, it fares in those areas so that it doesn't stall. And we already had the VGs on here for VMC control with more powerful engines. So the combination of those, and then at the last, when it finally did stall, even with these things, we had some vertical flow up the rudder, so we had this fence right here to stop that vertical flow. So the rudder now was fully effective to 30 degrees of deflection, and that took care of the heading issue totally. And that was, you know, before we owned the Aerostar. It was just a AD note, and that affected us as well as because we were modifying airplanes, and people couldn't use the flaps on their airplane. It was an opportunity for us to fix something. So Piper, they decided they're going to call the Aerostar the Piper Sequoia. In 1981, they had a brochure that came out, and And then a little while later, they came to their senses and said, no, it's a Piper Aerostar 602P. So we got calls from people and saying, hey, can you turn my 601P into a 602P? And the 602P engines were low compression engines, less susceptible to detonation. And we said, well, yeah, we could probably do that, but why would we stop at 290 horsepower? Let's see how much higher we can go. So we were able to certify the engines at 325 horsepower. And those sold like hotcakes. And people that had 3-year-old airplanes would come in, and I think it was 45,000 at the time. They could go from 290 to 325 horsepower with that engine change. And we already had the VMC issues solved with vortex generators on the first Superstar. And we soldiered on there with, then we decided, well, you know, the Superstar 2 is getting a little expensive, and so we should put intercoolers on the Superstar 1. And then we said, well, now what are we going to do? What are we going to call this thing? So we said, well, why don't we name it for the total horsepower? We're going to raise the power from 325 to 340 by putting on intercoolers. And the first ones were in the wings, just like the Superstar 2 was. So we're going to call it a Superstar 680. And we were really a thorn in Piper's side because a lot of the prime customers that had 2-year, 3-year-old Aerostars, they were trying to sell them 602s, and they really didn't have a big advantage. But they did cost 200 grand more than their airplane cost. And so we were selling Superstar conversions to a lot of the same customers that Piper was trying to sell their 602 to, and so the marketing guys decided we need a 700 to compete with Aerostar, and it was successful. And we decided, well, let's come out with a Superstar 3. But the props never worked out. As good as they look, they caused a vibration in the airplanes. So that was back in about 1982. I kind of have to laugh when I hear people say, oh, they got the new Scimitar tips. Yeah, we had that in 1982. But here's the unfortunate truth was the sales of the Aerostar with Piper just declined in '84. It went out of production. Well, that was a problem for us, just because spare parts kind of suffered. And during that time period, it was they eventually went bankrupt, and they stopped supporting the Aerostar because they didn't have the money to get vendors to supply the parts to them. So we bought it in 1981, mostly in self-defense. I had to call people and say, hey, have you heard about our new auxiliary fuel tank? And they would say, Jim, I don't need a fuel tank. I need side braces or main landing gear scissors. So here's our facility. That Aerostar on the side's all photoshopped. That wasn't there, but that's still not there. But we thought we ought to put that on the side of the building, you know, so somebody would know. So we have all the drawings to make an Aerostar, okay? And so we can make spare parts. And a lot of the equipment you need to make these spare parts, we don't have. So you send those out to a vendor, and they hydropress them or form them and send them back. And it's a constant struggle because we're low volume. You know, if somebody needs a skin for the nose, well, you could buy one, and it might cost you 30 grand, or you could buy 10 and it costs you 30 grand. So we buy 10 and keep raising the value of the stock room. Some of the parts on the Aerostar are made, the drawing says make from template number 123. Well, here's most of the templates that we took out of all the boxes. And, you know, I've got some of these say 1968 on them, but they're not even dimension drawings. They're just make from this template. And a lot of the high usage stuff we machine ourselves, have it cast at various vendors, and then machine them. These are wastegates and windows, turbochargers, stock room. This was one of the first parts that we got released, and it was torque links that Piper designed to improve on the original torque link. Unfortunately, they started cracking right here because somebody tried to make the part identical so they could use them both, but that didn't work out, so we made them like this, and they're a lot stronger, and there's no recurring inspections required. Most of you guys already have that on your airplanes, but it's just something we did after we bought the type certificate in it. And some of the things we make are just listed here. The propellers were quieter, and we got the prop tips on the 350 horse airplane at 25,000. They were going supersonic, so we had to reduce the diameter, and we hired a aerodynamicist to give us the twist distribution on the propeller. And we actually, it was very sophisticated at the time. We actually had a camera in the nose hatch area. We had a black light, strobe light system in the pilot's seat. And we had fluorescent tufts on the prop blades. So we could fly it and get a snapshot of what the props were doing. And that really made a difference, and we were able to get the exact right pitch distribution on the prop blade. And we probably couldn't even do that today, but at the time we were a little younger and more ambitious, and we got it done, and it worked out. Well, I was going to tell you one thing about, and I've said this before, but I asked, these test pilots, we had a really good test pilot in Seattle who came over, worked for the FAA. He was able to fly his Baron over, and we'd go flying, and he was a interesting, really super nice guy. And when we were doing all our stall characteristic stuff, he said, "Okay, Jim, if I say cut them, you cut both engines, because I can fly a glider. Okay, I grew up with gliders. I can fly a glider. You just shut off the engines." And then I asked him one day. I said, "Hey, Dick, do you think if we made more powerful brakes for the Aerostar that anyone would buy them?" And he said, "Well, this is the only airplane I know of that speeds up 10 knots when you hit the brakes." And the original brakes had a really hard pedal, but numerous times when people picked up new airplanes, they'd come taxiing back, and the pilot seat was broken, because they were leaning back on the seat and pushing as hard as they could just to do the run-up. They hadn't even taken off yet. And so it was a really hard pedal, but you didn't have a lot of braking capability. So that was a pretty easy upgrade. And there's just a picture of the hangar with airplanes in there. And we were doing restorations at the time, so we got a lot of experience with maintenance. And here's an airplane that we bought, and it came from Don Smith, and he says, "Well, it's a mess, you know, but it's a good airframe." And so we bought it, and it already had the crimson interior in it, and we got it, all of the pieces came with it. And that's when we were finished. That's the airplane, and a picture of that airplane. It really came out well. This was the old pillow-on-pillow interior design, which it was nice. It looked nice. It came from a King Air. We just copied whatever year that was, King Air. Put in a new panel and got rid of the plastic overlays, and it was state-of-the-art at the time. There it is flying. And we actually did a gross weight increase to this airplane. And we also put in the KFC 225 autopilot, or rather King Radio put it in for us. We gave them the airplane, and 6 months later they gave it back to us with this autopilot, and it worked perfectly. And it always has worked really well. But It's not a digital auto, I guess it is somewhat digital, but I don't know the answer to that. But it won't take any inputs from anything else, but it did have altitude and rate pre-select built into it. And at the time, to get that, you had to put in a $16,000 K346 altimeter, and this was a simpler fix because anybody flying the airplane single pilot needs pre-select. And a lot of people didn't have it, and all you'd do was just set the ADF indicator at whatever altitude you're supposed to be at, right? That's what they were used for primarily. So we decided, hey, we're restoring airplanes, we're making some money doing this, we need to promote the airplane. So we said, let's call it a 702P instead of a 602P, and that, my partner Steve came up with that. And we thought, hey, that sounds pretty good. So what is it? Well, it's a Superstar 700 with the pressurization increase, the new autopilot, and the gross weight increase. And that appealed to a lot more non-owners who said, hey, maybe I'll get an Aerostar, and they looked at the useful load and said, well, it won't do what I need it to do. Well, now it does. It's better than any other piston twin. So there's the specs. You've probably all seen that. And here's the pressurization. We've changed these components a little bit over the years, but basically it's 5.5 PSI up here. The red line's like 5.6, I think, because the safety valve will open if the outflow valve doesn't. And there's it's mostly a structural beef up, but we found this out. This area right here was weak, and these pieces go up at a 90-degree angle and over the top because the rivets holding these retainers in were in tension. And when you have a rivet in tension, it's not good. You want them in shear. So it pulled the heads off the rivets and blew the emergency exit out across the hangar and hit somebody's toolbox. So that was an issue. We had to fix that. So we pressurize all the airplanes. When we're done, we pressurize them now for maintenance, and we see a lot of... The nice thing about the Aerostar is you can always fix it. Some airplanes, you really can't get them back to the way they were when they were new. This airplane, you can. Just a matter of pressurizing it, finding the leaks, and fixing it. So part of the gross weight increase is to beef this area up because there's a lot of cracking that went on down here. And in order to do that, you have to take the nose skin off the airplane. And here's an original, we call it a hat section. And that we'll have some more slides on this going forward, but there's a lot of extra parts in this one that stabilizes the location of this pivot point. Another thing with the all Aerostars, when we did the gross weight increase, it was mostly drop test and changed the valves in the landing gear, and the wing was strong enough, but the wings all crack right here. You have cracks show up underneath the wing fairing, and so we said, let's make that part of the gross weight increase. We'll put this horseshoe doubler, we call it, on there, and it's critical that you pick up these holes and you don't elongate the holes because they're going through the spar. So once you do that, the problem solved as far as cracking of the wing skins. I don't, let's see, another area that we find a lot that we have, that's on the list of things you have to verify, is they have the right size rivets, and all these are the U-joints. This is where the elevator horn is attached. And we now have higher loads on the elevator, so we had to beef that up. So this was the idea. It was certified originally to 30,000 with 5.5, but we had to back it down due to RVSM. So we had engine-driven air conditioning, intercoolers, big engines, did some airplanes, did quite a few. Auxiliary fuel tanks are a hit, big hit. The first guy said, I'll do it, but you got to put an aux tank in there for me. Okay, Inconel exhaust system, that just got to be too expensive to make anymore. And I think that the pipes from Nisley Welding are fine. They're okay. They're about equivalent to the original new ones, but they're going to have to be replaced more often than the Inconel. This recently came up that, you know, there's an AD note to replace the clamps that hold the tailpipes on turbochargers for a lot of airplanes. But we don't have that problem because we don't have clamps here anymore. We have some pieces back here that are between the flange and the turbocharger, and they have studs sticking out of them. And then we put some lock nuts on that pipe. And then, you know, the original problem was not the clamps. The original problem with they lost 2 Aerostars because of tailpipes coming loose and blasting the firewall and melting the wing spar. And the problem was the weld right here. That was the problem. And this flange used to just be a straight flange and a 90-degree butt joint that was welded. Well, we made a flange that's machined so the pipe fits inside the flange, and then we weld around the outside. And we thought, well, what if the weld breaks? We're right back to the problem. So we put this, we have here, this is thick enough that we thread it, and we have what's called a shoulder bolt that goes through here and a tab that's welded to the pipe. So even if the pipe cracked, it might leak a little bit, but it's not going to rotate out of the way. The original pressurized airplanes had a cable that went out to a door that would shut off the airflow to this cabin intercooler. But it didn't work because once you closed it, you couldn't open it again. Okay, it's like trying to push a rope. So we said, well, why don't we make an improvement? Well, let's go back to some bleed air heat. So it took us a while to figure it out because we hadn't done any R&D projects for a while. So the first thing we did was spend a bunch of money and make a electrically controlled flapper valve here. And what we found out was that cooler works pretty good even with no airflow flowing through it. So we said, okay, bypass the cooler completely and see if that's hot enough. And sure enough, it was 250 degrees. So this whole kit expanded quite a bit before we were done. It cost a lot more money than we intended. But once you're flying at altitude, you don't need the heater. We made it originally just to be an emergency backup for when the heater quits, because they all seem to at some point. You can pull on the bleed air. Well, now you still need the heater when you're on the ground in Chicago or someplace, but once you're flying, especially climb power, you're going to have plenty of hot air just with bleed air heat, and then when you're at altitude, you have plenty of air. But we need to leave that system in. This is the VS Aero model of the winglet airplane, the winglets on the Aerostar. And I think they made several runs to get it figured out, but it was like $1,000 a run. And they said, you want to do this? No, we're done. But you're happy with it, we're happy with it, let's not experiment anymore. But they came out really well, and we just received a patent on the winglet because of the unique features that went into it. It was a 4-year project, and I'm sure we're still not making any money on it, but people wanted them, and we said, well, if we're going to make them, let's make them really right, and we hired the same people that did them for Boeing. So it's a fully blended winglet. You know, when we talk about maintenance, one thing that comes up is, you know, you have flap tracks here. And I was going to have Bob Lepper told me a story about his airplane, his little 600. And those flap tracks, I'll bet on a lot of the airplanes, they've got paint on them, or they're corroded, or they're not lubricated like the maintenance manual says. And, you know, you run the flaps up and down, they work okay, they're fine. But if we could get Bob that microphone, he's back in the far left corner back there. You know how to turn that on, Eric? I don't have a good picture of those flaps, but it just reminded me of the story, so maybe Bob can give us a couple minutes worth.
Okay, well, I'm unaccustomed to public speaking, so bear with me. Anyway, this goes back, well, about 1990 or 1991. I was, had an instructor that was giving me my a check ride. Was not loud enough? Can't hear him. Okay. Anyway, back in the day, this guy was a Part 135 check pilot, so his idea of any kind of a check ride in any airplane was a Part 135 check ride, which is pretty rigorous. But one of the things that they did back then, which I didn't expect, was a bulk landing. And in an Aerostar, if you've ever done a bulk landing, it's kind of exciting. You know, you're in the flare, you're about to touch down, and he says, go around. Somebody just taxied on the runway. Well, the drill is mixture prop throttle, flaps up, gear up, and you have to remember to, while you're still flying the airplane, to go back and stop the flaps at 20 degrees. Because what happens is if you don't, you're going to lose more lift than you than you need, and you're going to have a problem. So anyway, what happened with me is the airplane suddenly started rolling to the right. Well, I'm at 90 knots, 95 knots, you know, a few feet above the runway, in high drag configuration, and I obviously never been there before, had no idea what was going on, but it dawned on me that from what I could feel on the controls, so I reached over and put the flaps back down. And the Part 135 instructor had a heart attack because he thought that was absolutely the wrong thing to do. Well, guess what? The airplane straightened right out. And after getting back to so I flew with the flaps down 60 miles back to my home airport and landed, and get out of the airplane, and the flaps looked fine, retracted, no problem. Well, unbeknownst to me, my maintenance guy had decided that he didn't like having to grease the flap tracks, so he cleaned them off and sprayed molybdenum disulfide on them, okay, a dry lubricant. Well, they still worked fine, except when you try to retract the flaps with an air load on it. So when's the last time you retracted the flaps in your Aerostar with an air load? You always just retract them on the ground after you land. Well, what happened was the right flap retracted, the left flap didn't. So that caused me to now make sure that my airplane has lots of grease on the flap tracks. And when I look at airplanes on the line, it's like Jim said, you know, the flap tracks are usually in a pretty neglected position on the maintenance schedule apparently, but it can sure fill your shorts up real fast if they don't retract at the right time. They don't work at the right time. So anyway, that's my story, and I'm sticking to it.
Okay, thanks, Bob. So the winglets work really well, and here's a picture of an airplane with winglets. We're at 28,000, indicating 241, and I calculated true airspeed is 350, but that one also had the bigger engines on it. So here's an overhead duct. A lot of people, the original overhead duct had the speaker up here, and we always thought, well, why don't we get the air up there so it can blow black in your face, and we'll put an extra outlet up there, and made this new overhead duct, and then we had to widen this thing so it didn't block the airflow from the speaker getting up there. So that's an option that makes the air conditioning work way better. And this has an extra outlet back here, and it works really well because it needed more airflow. You know, it's one of those things where you had really cold air coming out of the outlet, but the sweat's dripping off your nose. So this really improves air conditioning quite a bit. So I think that the airplane is way better, and it's kind of attained that initial objective was make it the best airplane, the best piston twin possible. So now on the maintenance side, we're doing more maintenance, not as many restorations, and we've learned a few things, and maybe I can share some of them here. This is a picture of the nose gear from the front, and of course, we cherried this one out. A little better than new, but you can see everything is labeled. So here's the actuator, and the distance between here and here isn't very much. And when that actuator rod extends, it doesn't have a lot of mechanical advantage to retract the nose gear. And that's why you have to get the nose gear up when you're at 130 knots or below, because it won't go up. And on the jacks, if you put the gear up, you can hold the gear down with your little finger. And it's all because you don't have a lot of leverage there, but it works okay. And the doors are operated, there's a torque tube that goes from one side to the other, and on each side there's this rod that goes down and attaches to the main gear door, and you can see it has to go through a hole on this side. And the hole was a weak link. Just for the guys that have the newer nose gear, the Weeble nose gear, there's a shear pin right here. So if you ever go out to your airplane, the nose gear doors are drooping open, that's probably what's happened. It's sheared that pin. On the earlier airplanes, the arm coming off the nose gear that actuates this rod right here, the arm coming off the actuator, it just breaks the casting off. And then you need to send it in to us, and we weld one back on and have it machined, and it's more of a issue than just fixing a shear pin. I went somewhere, I think I went into Palo Alto and demoed the airplane, and that's like 2,500 foot runway in a Superstar 2, and went out and flew it and came back, and the guy said, let me show you how to land short, you know, because I go in here all the time. Well, this is a lot heavier airplane than what he had. And he came in what I thought was too fast, and we still hadn't touched down. Halfway down the runway, and I just pushed both throttles up. I said, we're going around, and I got it. And I thought, boy, this is really quiet, you know. And I looked over, and we're at 2,000 RPM. I didn't think about getting the props up. I was just in a panic that we're going to run it off the end of the runway. But we came back around, and he hit kind of hard and dropped the nose gear down, but it worked okay. It was, you know, he kept the speed really low and just kind of plunked it in. Well, my nose gear doors are hanging open. So now what am I going to do? So I pulled one of the doors, this bolt off right here, and I had some hose clamps. I just clamped that thing back together with a couple of hose clamps that got me back to the shop and where I could fix it properly. But there's a lot going on up there, and there's a tremendous load right here. And some airplanes have a connection over here, and they have a V-shape drag brace. Well, the Aerostar only has it on one side. This is called the drag brace. And you can see there, if you push back on the nose gear, it's going to put a bending load on this part of the landing gear, and if you pull it forward, it goes the other way. So what does that do? Well, here are the two major parts that make up that. The whole objective here is to have a place where the pin can rotate and not move, the pin that goes through here. And there's a bushing on the outside. This is the inner drag brace, inner hat section. I'm sorry, inner hat section, not drag brace. There's a bushing here and a bushing there. Then it goes through the wheel well skin, and there's an outer hat section. Okay, they call it a hat because if you turn this 90 degrees to the left, it kind of looks like a hat. Okay. And that area always seems to get loose. It was never strong enough. But these three rivets are holding this bushing in place. And this piece right here, you could replace that if it cracked. Somebody replaced one time. We see this where the drill chuck of the drill hit the new part when they were putting it in. and they elongated all these holes. So you might as well, so we threw it away and put a new one in there. And then these holes were too big, so that means you had to, of course, then this part here gets cracked, and that's the area that gets beefed up with the gross weight increase. I've got more pictures. Sometimes the inner hat section cracks. Well, it cracks right where they took all the material out, right, to put the rod through it. So it's cracked down here and right there. And this one didn't have any of the beef ups. So that's why we focused, and that's why we made this guy, which is probably twice as heavy. But you probably, if you don't damage it, but tow in the airplane, you probably never have to touch it again. So that's the difference between the original. You see, this is the block, aluminum block that holds the bushings where the pin goes through, and that's where the drag brace pivots. In order to fix that, you have to take the skin off. Well, we mess up the paint job when we do it, but we have to get rid of the paint so we can find the rivet heads so we don't elongate those holes. And that's the beefed up area just for the gross weight increase, but a lot of times when you take the skin off, you say, oh, look, this is all loose, that's working, this, you know, so now's the time to replace all that stuff. The 600s aren't as bad as the pressurized airplanes because the nose weight, if you weighed one, is maybe 400 pounds on the nose, where the pressurized can be 600 or 650. Same, much higher load on pressurized fuselages. So that's why we focus a lot on nose gear structure, and most of them need something that come in. This one's been all beef. This is the new style inner hat, but we didn't, you know, paint everything. After the guy painted, he was my best mechanic. After he painted all that, you know, he had a respirator on, pumping clean air in there, but he's up in the wheel well, spraying all that polyurethane paint, and I think that's the last one he ever wanted to do. And here's one with the whole inner skin replaced. And of course, you know, you have to unrivet all this and all that along there. And then you put in this new, that was probably all new parts. Oh, this one's just one where the bushing fell out when they were assembling it, and it ended up in the outer hat section. Yeah, when we took it apart, we found, it was, the pin was wobbling. So we said, well, there's something wrong there, and found out the bushing had fallen out. So if, and obvious, you know, they must have replaced this part trying to work through this access hole. They didn't remove the skin. Well, you're never going to fix it that way. So if the guy is afraid to take the skin off, or you're worried about your paint job, then you probably, you know, you need to go somewhere else. And we can fix this. It's not hard, but it is nice if you've done it before. Okay?
Jim, I think you told me on the phone that you could do those 6 rivets without taking the skin off?
Yeah, I think you can. I'm pretty sure you can.
With highlights?
Yeah.
So you would take the pin out, this is take the nose wheel apart, take the pin out, and then you can read the holes.
Yeah. I think you can if it's a blind rivet where you do it from the outside. Aren't high locks from the inside? I'm not sure.
With the nuts toward the...
Yeah, nuts out, then you could do it if you could get it in there. And it looks like you could by taking the bushing out. You could probably put them. But you know, there's a casting holding that in. There's a casting on the inside right there. You could put, you know, you could elongate the holes and put Cherry Max rivets in it. I think that's what's in it now.
Yeah, that's what's loose.
Yeah, you can go to the next size up and probably last you 10 years.
Jim, what's the budget number for a new hat section?
Well, just to do the gross weight beef up, it's around $6,000 to take the skin off. Now, what you're already in there, it's probably another $6,000, $7,000 for this guy, all built up. John, do you know the answer to that? Okay, $8,300 for inner and outer hat. No, but the labor, if you take the skin off, that's a big part of the process. So, yeah, if you're going to get into Then you need to take the skin off if you're going to start replacing hats. You could spend a good 20 grand. Yeah, but then you're done. Yeah.
Is that only for the gross weight increase, or is that just if it needs?
That's if it, no, the gross weight increase is $28,500 for everything. Of that, about 6,500 is taking the skin off and doing that upgrade. I mean, how do we come up with 28,000? Well, the wing patches take a good week aside to do. The nose gear takes 2 weeks if you're lucky. And then you find something else is broken in there, so now's the time to fix that. But that's how we came up with the price for doing all that.
Jim, you're thinking about that, because you had to replace that section, and 61 feet, 62 feet. Would it make sense at that stage just to go ahead and do the work for the 6850 gross weight increase, even if you're...
Yeah, absolutely. And you can go ahead and get all the work done, and then when you get the gross weight increase done, you'll get a credit for the gross weight increase work. You might spend 20 grand, but 6,500 of it would count towards the gross weight.
And that would increase the value of the airplane for somebody else.
Sure. Yeah. It's a weak link. It's a weak area.
But to have the gross weight increase, you have to have this 350 horse engine?
Yes. For a single engine, minimum requirement for single engine climb.
What's the difference between my 340s and the 350s? Is that just props and animal pressure red line?
Yeah, it's about 25 grand. Yeah, it's props. To get your props cut and retwisted and turn up the manifold pressure screw and get a different red line on the manifold pressure. Now, you might say, well, how do you know where to put that hole? Once you take all this stuff out of here, you put a new skin in there, you're going to just lay the skins down and mark it? Well, yeah, you can do that. Or you can use this tool. We send it out. John has, I think, 2 of them, don't you, John? Yeah, so it picks up the attach points for the nose actuator and the trunnions for the nose landing gear. So then you locate where that hole, that pin is. And you see that piece then lines up with this pin. That's that same patch. We've got some duplicates there, but this is becoming, a lot of people want to buy that now, and of course we were low on Inconel tubing. We had to buy some more Inconel tubing, and we can start supplying those tailpipes again pretty soon, I think. This is what you never want to see. That's steel on the magnet. When you do an oil change and you cut open the oil filters, and then we rinse them out in a plastic bucket and stick the magnet in there, and that's generally cam and lifter metal. And we always pull the pickup screen. We did a pre-buy on one right out of annual, and the deal was, I'll buy the airplane for 300 grand and you pay for everything that's unairworthy up to some number. You know, if you have to put an engine on it, and he had to put an engine on it because the pickup screen had a handful of metal in it right after an annual inspection. So they didn't pull it when they did the annual. And that was about the time where they were having Babbitt material coming apart and rod bearings on Lycoming engines. One guy came in and he says, well, I think I had kind of a hard landing. Yeah. So that's what it looked like when we took the skin off. That's kind of interesting. See, this is the only thing, these are the engine mounts, nuts. And there's not much sheet metal holding that together. And if you see this, that's an indication that those rivets have been pulled because the engine mount goes into a nut right there, and it's captured by these 2 pieces of sheet metal. Just something to know. If you see fretting, that's called fretting or smoking rivets, it's probably loose in there. You probably need to get those rivets replaced with next size up. Anybody that's been working on Aerostar's landing gear system would look at this and say, you know what, there's supposed to be 3 washers there, and there's about 6 of them in this picture. I wonder what's going on. Oh, look at that. That's dragging there. That's dragging on the cutout. So that whole landing gear had to be just re-rigged, actually, is all that was wrong with it. But you really need to, it's really nice to have somebody that has experience so they know what to look for. And you might, you know, a good mechanic would see that, would see this, because you're going to look at all that stuff. This is the main rod between the landing gear and the bell crank that operates the door. Oops, wrong button. What did I do now, Joel? Okay, let's see. Okay, this is, well, you know what? This is actually a video, but I don't know if it'll play because it was designed to play automatically. It played automatically on my machine, but it doesn't play here. But right here, you think there's any way to make that play, Joel? It backed it up one. Well, anyway, the guys said, come down to the hangar and I want to show you something. And they said, pull up and down on that tailpipe. So I went over there and I went, no, it's not moving. No, they said, no, pull up and down on it. Okay, put both hands on it. And I pulled it down and it moved about 2 inches. And it's all because the bracketry for that turbocharger, one part is attached right here, and you could see some crud here like that's been moving. Well, this moves back and forth, and there's another brace, a vertical brace. Well, that doesn't like that. And you can see the hole in that thing is elongated. So that didn't happen on the flight up here. Okay, that's been that way a long time. And I'm surprised it didn't break one of the brackets, but that tailpipe moved down far enough it hit the engine mount. And it was just loose and hadn't been, so I'd tell all the mechanics, and maybe you want to do that and tell all the pilots, maybe at some time when you're working in the hangar or whatever, grab the tailpipes and put a little force on them and see how much they move. And they really shouldn't move much at all. But that one moved, you know, a good 1.5 inches maybe. Just something to look at that you could do. You know, you don't need to be a mechanic to look at things, right? And move things. And that's a kind of a rule for mechanics. You can look at it all day long, but put your hands on it and see if, you know, if all this stuff is, if any of it moves. These are just pictures of some really bad workmanship. Here's what that valve should look like. This is the float valve in your wing that lets air into the wing when you drain the fuel out. And somebody had repaired this one. They'd repaired a leak in the fuel tank, and they glommed this sealant all over both of the valves in the wings. Here's another job that, I mean, this is criminal, you know, to do something like this. Evidently they had some repair and they had to take this fitting off the aileron. This is your aileron bracket. They ended up making a mess of it. We've seen this before a few times where these are aileron tubes that get dinged somehow. There's another one. So we have a good look at all that for sure. And that's something you could do too if you wanted to open some panels and look in there. Do not open any wing panels with an electric screwdriver, by the way. You might open a fuel panel and it'll blow up. Okay, so just use a speed handle. Yeah, years ago when they first came out with those, they sent around to mechanics pictures of the guy laying up against the wall. He opened the fuel bay on a 414, it's a wet wing 414, and it exploded and killed him. Yeah, if you put the idler arm, if you put the tube connection to the wrong hole in the idler arm and it drags on this cutout, we'll just grind it out a little bit. Yeah, and same thing over here. So you can hear that when you move the controls generally. You can hear something. That's why we looked in there. No, it doesn't like that. Another area that inboard on the wing, there's what's called an intercostal. It's just a sheet metal piece, and you can see we cut a big hole in it here. And behind there, you can put high locks in areas where the rivets are loose or working, but you can't get back there without having this hole in there. And the hole is structural, so we offer this doubler. And those are not floating nut plates. Those are fixed in a position because the engineer wanted this to carry loads. So you can install this plate, and then you can get back there and see where your control cables are run. Those are new control cables and wiring. And it's kind of an area that maybe it'd be nice if they put an access panel in there to start with, but they didn't. So now you can open that up and look in there if you install that. These are just a couple slides of the fuel system and you could open these kidney panels and you get out the maintenance manual and you can figure out how to get the gear door open. And you could open that and look in here for any leaks. Not really much you can do about it if you find it, but this is just an interesting picture. Your heater duct comes in here and it has to make a turn through that access panel, so they went to 2 instead of 1 for a tighter bend radius. And it's in your left-hand wheel well, and this is all covered up with either a Royalite plastic panel or a fiberglass panel. And if you see that panel's all deformed, that means those ducts are leaking. That's heater air that's really hot, and I've seen a lot of them deformed. And we're doing a pressurization test. Well, take that off. Those snake through there and connect to some tubes that are inside the cabin. And this is just, we always sometimes talk about flapper valves. I just thought you might want to see what they look like. This is a fuel sump. Now, this should be turned 180 degrees to line up with this one properly, but it looks the same on the other side, except the other side has a fitting, and that goes to your heater fuel pump. Okay, that's how I know this is the front, and this is really the front because it doesn't have the fitting. But anyway, this is the same here. One-way check valve. Okay, so fuel can come down from the fuselage tank bag through the screen and out into the common sump. Okay, and the common sump is right here, and the fuel coming down from the wing is right here. It goes into the common sump. And then they both come in here, and when you drain the right wing, it's really draining the common sump. And the right wing is coming in here, and there's a check valve right here that only lets it go that way into the common sump. And it's the same type of valve. It's called like a mousetrap valve or something. A Sweeney check valve is what the name of it is. It's made by a company named Sweeney. And it's just hung from a pin, and the fuel pressure will close it. The head pressure will keep it closed and not let it go from the wing to the fuselage. That's the idea, okay? And it won't go back into the wing either. Boy, it went all the way back to the beginning. But that's pretty much all I had to say. It probably ran too long anyway, but it's 2 o'clock already. Any more questions? Go ahead.
I bet the fuselage tank filled that'll drain into the wing for a week or 2, 6, 7, 8 gallons. Theoretically, a check valve's supposed to prevent that.
Yeah, well, they're 40 years old. Yeah. Yes, sir.
There's a statement in the service manual that talks about smoking rivets. That's normal on the, I think on the lower skins, inboard on the Normally, you can see that, oh man, those rivets need to be reset.
Yeah, I had a video, actually have a video here, but it didn't, for some reason, didn't show up even, let alone play. I don't know why. Maybe I'll scroll through it and see. You just push up on the skin. A lot of people say, well, I got smoking rivets. Well, I'm going to replace all the rivets. Well, are the rivets loose? They're not loose necessarily. In that inboard section of the wing is also the pneumatic pressure relief valves. And your pneumatic pumps have carbon veins in them. And when they wear, that carbon can go down to the pressure relief valve and blow out in that wing section and cause it to look like the rivets are moving. But the thing to do is push up on the wing skin and see if the skin is moving. And if the skin isn't moving, then the rivets aren't loose.
Just rub your finger across it, see if you
Well, you're gonna,
sit on the finger.
if you're gonna get, you can get soot from the carbon veins, not from the rivets being loose. That was my point, is it's not necessarily, if you have black soot, it's not necessarily loose rivets. Right, Don?
There's always a big lot of free spot that you have connection with. That doesn't help you with the and good stuff.
But Jim, I mean, if you end up with smoking rivets, that's the time to put that kit in there and put them hot bolts in there, and then you're ready for your upgrade to 6850.
That's the time, and that's the time to put in the intercostal opening, because then you can get to the back side of the rivets, because, you know, unfortunately, the rivets countersink all the way through the skin. And so the stem of the rivet, now the hole is bigger than the stem of the rivet. So you can't just keep putting bigger and bigger rivets in there. You'd like to have something that actually holds the skin tight to the spar cap, or the stringer in that case.
I have a question, Jim.
Yeah.
When you have the kit that uses bleed air for heat, there's a limitation on using that and the combustion gear at the same time. What's the reason for that? Will it cause the combustion gear to overheat?
Yes. Yes. It'll cause the thermostat to pop. Yeah, we didn't want to keep adding everything, but we had to add a micro switch so that if you do that, it shuts off the heater. Okay, so you probably can't hurt it, but probably should never say you can't hurt it. The only guy I say he couldn't hurt the airplane was a fighter pilot with the F-100. He said the first thing he told him in school was, you can't hurt this airplane, no matter what you do. That was Ed Edlin. Remember Ed? Okay, that's all I have. No further questions. We'll move on.
Thank you, Jim.
Thank you.
Mark?